let's take a look at 8.3.2. How can we solve it? So now that we've learned polynomial division, we're going to have to ask ourselves, well, how can we find the possible factors? I gave you a hint when we were going over the homework that you can plug in C values. In other words, try plugging in roots and seeing if the remainder is 0, and if the remainder is 0, then those must be roots. But how do we know what C values to try? Okay, so that's what we're going to be looking at now. And a little bit of warning, this is slightly painful. It will be a long problem, but we're going to get through it, and you're going to get through it. So let's take a look at 8-106 to start off. Your task is to determine all of the roots of the polynomial below and then write the polynomial in factored form. So we want to start off with a little discussion of the rational zero theorem. So the rational zero theorem, again, is going to be discussed in a Math Notes video that you guys should check out. But to review it here and to summarize it quickly, it says that in order to figure out what potential zeros are, you need to look at the last term in the polynomial and the first coefficient. Okay? Which in this case are 6 and 1. And you're going to write the last over the first. So 6 over 1. And then you're going to look at all the factors of the 6 and all the factors of the 1. And together they're going to tell you possible roots of the polynomial. So if we do a little factor tree, 6 can be factored into 2 and 3. And then it can always be factored into 1 and 6. So we have 6, 3, 2, and 1. And because our first term is 1, it only has one factor, which is 1. So it makes it a little easier. And then we have to put plus and minus in front of everything. So we have 8 possible roots here that we want to check. We have plus and minus 6, plus and minus 3, plus and minus 2, and plus or minus 1. Those can all be roots or the C values that we're going to use for our remainder theorem. Oops. Alright, so now we just want to start testing them. I'm going to start with 1 first because that's going to be your easy one. And remember, we're going to plug in different x values. We're going to plug these guys in for x and see what our remainder would be if we divided by that. So when I plug in 1, that's 1 to the 4th minus 1 cubed minus 5 times 1 squared plus 3 times 1 plus 6. So 1 minus 5 plus 3 plus 6 gives us negative 5 plus 9, which would be 4. So that has a remainder. So 1 is not a root. Let's try negative 1. Negative 1 to the 4th. Minus negative 1 cubed. Minus 5 times negative 1 squared. Plus 3 times negative 1. Plus 6. 1 minus negative 1 minus 5 minus 3 plus 6. So that becomes 2 plus 6 minus 8. So there's a remainder of 0 with negative 1, which means that if negative 1 is a root, in other words, we're hitting the axis at -1, then x plus 1 has to be a factor. And that's what's going to get us started. So I started with the low numbers because they're a little bit easier to do. And it narrowed it down, starting with 8 possibilities to one that works. So let's try that out. We're going to use x plus 1 as a factor. So, x plus 1, x to the 4th goes here. I'm going to move this down a little bit. That means that this is x cubed. This is negative x cubed. That this square plus this square has to equal that, which means this is plus 0x cubed, because it already adds up to negative x cubed, which means this is plus 0x squared. And that gives us 0x squared. And this plus this has to equal negative 5x squared. So this is negative 5x squared, which makes that negative 5x. And this positive 6x. Keep going. Well, positive 6x plus this square has to equal positive 3x, which means this has to be minus 3x, and this has to be minus 3. So minus 3 times that gives us positive 3. And we've made a mistake because we should have a remainder of 0, and instead of a remainder of 0 we have a remainder of 3. So somewhere in there I made a mistake. Let's take a look. Well, the mistake we made is that this was supposed to be x plus 1, not x minus 1. So let's try it again. X plus 1, so this has to be x to the 4th. That's x cubed plus x cubed minus 2x cubed now, in order to add up to negative x cubed for those two, which means this is negative 2x squared, which makes this negative 2x squared down here. And just, I'm getting lazy here with the colors. Those two have to add up to our negative 5x, so this has to be negative 3x squared minus 3x minus 3x. So those two have to add up to positive 3x. Right now they add up to negative 3x, so we got to do plus 6x there, which makes this plus 6, makes this plus 6, and then if we had a remainder it would be in this square, but the remainder is 0 because 6 plus 0 equals that 6. Okay, so now we've narrowed it down to x plus 1 times x cubed minus 2x squared minus 3x plus 6. And we need to factor the new one here. Well, We still have a 6 at the end. We're still going to want to test factors of 6 over 1. We've already checked 1 and -1. Let's try 2 and -2 and see if that goes into here. If we try 2, that's 2 cubed minus 2 times 2 squared minus 3 times 2 plus 6. We're going to have to do another round of division so we can take our third degree polynomial down to a quadratic or second degree. So that's 8 minus 2 times 4 minus 6 plus 6. Oh, awesome. Hey, look at that. 6's cancel, -8, +8 cancel. So it looks like +2 is a root, which means that x minus 2 is going to be a factor, and we just have to divide that third degree polynomial by x minus 2. So let's do that right now. X minus 2. So here, this square is now going to be that one. That's the polynomial we're factoring. So this is x cubed. That's x squared minus 2x squared. This plus this equals that. So we have plus 0 x squared. I'm going to zoom in a little bit on this. Plus 0x squared. So this must be plus 0x. And this is going to be 0x once we multiply that. Now, this plus this has to equal -3x. Which makes this -3, and this +6, which is great because this plus this has to equal 6. So again, our remainder is 0, and this gets to fill in this parentheses, x squared minus 3. Okay, so we are almost done. We need to get 4 roots. Right now we're down to 3 factors. So to get this last one right here, we're going to use 0 product property. We know that to find roots we can set this equal to 0, we set y equal to 0, and set each of these equal to 0. We've already found one root at -1, one root at +2. So to find this root, I say x squared minus 3 equals 0. So x squared equals 3, and x, after I take the square root of both sides, equals plus or minus square root 3. Move that off to the side. Which means that this parentheses can be broken down into x plus root 3, x minus root 3. This is still x minus 2, x plus 1. And if you multiply all of those together, then you get the original polynomial, which is right at the top here. So once you multiply those out, it's x to the 4th minus x cubed minus 5x squared plus 3x plus 6. And we are done. If we graph this, we would have roots at -1, positive 2 square root of 3, which remember is at like about 1.7, and negative square root 3. So our polynomial looks something like that.